So Keith, we are here today to discuss the leak defense system and its technical acumen, right? And why you guys for 15 plus years have had a pretty superior product in the field, right? And not just the valve itself, but you have a comprehensive system. And so to the audience viewing, we're going to go over today technical components, the quality of the components you're using in the system, and ultimately why those stand the test of time.
So selling points, a contractor wants to get in front of a customer and differentiate us. An engineer wants to differentiate us. He wants to put the best thing out there for the customer. So whoever you're dealing with, these four components can be used to compare us to anybody else out there in the field.
Okay.
So color, touchscreen, interactive control panel, commercial grade product, hot and cold water, high torque value, a torque limiter on this as well to protect the electronics and protect the gears. So we'll go over those a little bit more in detail. The third thing that we mentioned in the previous video is the adaptability to any size home and really commercial projects. So the smallest residential condo all the way up to large 10, 15, 20,000 square foot spread on residential systems. And then the fourth thing is we are the best in detecting flow. We are the only company out there, bar none, that can detect live flow pipe leaks better than anyone out there. 365 days a year, 24/7, without turning valves off, without doing any other interactivity with the system. But let me just show you some of the features of the valve actuator and the ball valve system. Like we said before, we can use this on any hot and any cold system. Most of our competitors cannot. It's only a cold water system only. High torque. So we've got torques all the way up to 2,900 inch-pounds. But what we do is we adapt it to the torque needs of the ball valve, and then we expand that out. We have an engineering safety point. For instance, on this system right here, I've tested this system. Even though we have a nameplate of 133 inch-pounds on this one, the actual torque value on this is about 400 to 450 before it backs off.
So you got a lot of proof in what you just said, right? But best in the business, right? Best at flow detection. So let's put that to the test, right? Integral to this, you have a thermodynamic coupling. Tell me about that and how that actually monitors the flow.
Right. So we've got a probe device in here that will detect water flow in a unique way. We've got patents on it, have patents on it for years and years. It's a device that detects differential in temperature when the water flows across it. And so we can actually detect drips per second.
Okay, down to 0.001 GPM.
0.001 GPM, which is drips per second.
Okay, which is minuscule, but it's still detecting that amount.
Right. In order to get that type of sensitivity in the market, you would have to spend about $20,000, maybe $15,000, $20,000, $30,000 to get the sensitivity that we can do. Okay. So for the price that you're paying here, not only does it have low sensitivity out there so it can detect and be calibrated to very low flow, the other thing is that since it's thermodynamic and it's got two probes on it, we don't need any filtration on the front end side. We don't need screen filters. We do not have a magnetic, rotating, mechanical device that will fail. And believe it or not, all mechanical devices will eventually fail, given enough time and enough corrosivity, enough water impurities, and that sort of thing. So these devices have been in the field utilizing this technology for 16, 17 years in some of the harshest environments, water quality environments in the United States of America. So we receive these back on occasion when someone wants to upgrade the system to a wireless system or other features that we keep building into our system. We look at these, we inspect it, and we see whether or not the probes have been coded and whether they misbehave and act differently, and they don't. Whether they need to be recalibrated, and they don't. Whether there's any type of a pitting on the stainless steel, we see no degradation over at least 15 to 17 years.
Okay, so you got a tried and true system here, pretty much.
Absolutely.
And to the questioning audience, right? And there's somebody who wants to compare apples to apples. You just mentioned you got a stainless steel probe in there, right? With no plastic components.
Correct.
And some other people in the market, they have plastic or they have screens, whereas that's completely, it's almost a commercial grade product and it's maintenance free.
Correct.
Okay.
Let me tell you what's wrong with plastic. So plastic obviously is plastic, which means it moves over time. So the specifications on it, the expansion, the contraction, especially if you have a mechanical device inside there, or if you torque the connections on these devices, on these plastic devices, you can get cross-threaded systems very easily. Even professional plumbers do this on occasion. The other thing that happens with a plastic device is you lose the grounding integrity of the copper system in the home. So it's an electrical safety risk. So you have to have either an electrician or some other type of installer come in and inspect if you do some kind of a wraparound on it. The other thing with a plastic device is it can't take the PSI and water hammer that our systems can. So this is designed up to, depending on the temperature, 300, 400 to 600 PSI. So that's what this system right here, and it's a system that has got great seals inside there. And quite frankly, if you do have, let's say for instance, a high-rise that burst their PRV in there and you apply 110 stories of foot head of pressure on this, the only failure mode when we jump this into the multi-thousands of PSI is we get a little drip on the seal right here. So it's not going to explode like a plastic device would in that case and cause a bigger leak.
Yeah, we see a lot of offerings in the market. They have plastics integral into the system or actually in the valve body itself. And so we eliminate all that noise with this. Absolutely.
Okay. Now, you see the plastic body right here, and the reason we have the plastic body on the enclosure for the actuator is so it's got RF transmissibility on it.
So the signal can get into it.
Absolutely. We've got an antenna internal here. We've got a proprietary control board on here. And so we have to get that signal outside. And so this serves a great purpose.
Okay.
The other features that this has, apart from the high torque, high temperature, high pressure, is we have a manual override on this. So in the event that a customer, let's say, loses power, and we're going to simulate losing power right here.
You get a disconnect, a kid trips on it or something inadvertently. Or,
absolutely, whatever it is. You know, the power goes out, my diesel generator ran out of fuel, my batteries ran out of juice, but I want to operate this system. What I do is I take this auto, I switch it over to the manual mode, and I take my hands here, and I open or close the valve to whatever position I want it to be in.
So with or without power, you could still manually operate the valve?
Absolutely.
Okay.
The other key thing that you may not have noticed is when you compare us to some of the other competitors, they have to have tools to open and close it. So how often does the tool get lost? Once you get it in the box, you install it, the contractor throws the tool away and all the accessories, and you can't manually engage with it.
It's like that dishwasher wrench that always, or garbage disposal
wrench. Exactly. So once
and you just did it manually right there.
I just did it manually. So it does not take a lot of hand pressure to turn that. Even if you got pressure in the pipe or you have flow through the pipe, it's very easy to do.
Okay.
And then when you put it back into the automated mode, you'll pop this back in, you'll throw it into the auto mode, and you're back up to snuff when the power comes back on. Something else that actually leads me to another issue is some of our competitors use solenoid valves and not ball valve electric valves. And if you have a leak on their system and it closes the valve off and you lose power, for instance, electricity goes off, trees hit a power line, electricity pops off there, and if it's in an alarm state, pulling that solenoid power is going to reverse the position that the valve is in, so you're going to feed that leak once again. So if the power goes off and this system is in the closed mode, in the alarm mode, and power comes back on, it's going to stay in that closed mode. If it was open when the power went off or the generator lost fuel, when it comes back on, it's going to be in the open mode. And what you just saw there was an exercise mode. So every time, occasionally we exercise the program, open and close the valves to maybe break through some of that calcium deposit over time. Or if it's power cycled and it's not into an alarm mode, we exercise the valve in that condition state.
Okay. So we reviewed here a lot of the technical innards of this. And so what offerings, what sizes do we have in the valve itself?
Right. So we've got 7 basic sizes and then some on and beyond that. So 3/4 inch, really we can offer the customer up to a 6-inch product for any need that he may have. So size is no problem. And the beauty about that is some of our competitors only offer a 3/4 inch. So if you've got a semi-large home that takes a 1 inch, you're going to get a pressure drop across that. If they need a 1 1/4 inch and you put a 1 inch in there, you're going to get a pressure drop across that. So you've got the minimum pressure drop across this, which is basically a full port open valve. And so really the only pressure drop you're going to get is if you get up to 6, 8 feet per second velocity in here, you're going to start seeing a little bit of pressure drop. But if you're concerned about that and the customer's got a $10,000 water massager in his shower and he doesn't want to lose 1/10 of a PSI, we can accommodate that with whatever size the contractor wants to install. One of the things that the sensor allows us to do is to never have to calibrate it, never have to maintain it, never have to inspect it, never have to replace filters as some of these other devices have. So it's a full install it and forget it until it alarms and gives you an indication. So reduced number of callbacks. That's a key thing with contractors. If you get a lower cost product that you may like and think is going to last, if it fails in 6 months, 12 months, 18 months, you keep getting those callbacks. Or if it can't interface with a complex home, you keep getting those callbacks. Contractors don't want callbacks. They don't make money off callbacks.
Yep. They're usually paying for them. Understood.
Right.
All right, so Keith Zander of Leak Defense, we've overviewed the valve, and in segment 2, we're going to move into a little bit on the control panel and the operations of the entire system.
Very good.